This video is on graphing linear inequalities in two variables. The graph of a linear inequality in two variables is the set of all points that are solutions to that inequality. The equation related to the inequality defines a boundary line, and the inequality symbol, that is the less than or the greater than symbol, determines the half plane that represents the solution. So let's take a look at this diagram here. So the boundary line is created when you take the inequality and replace the greater than or less than sign with an equal sign. That gives you this line. Then you want to determine, based on the greater than or less than sign, which side of that boundary line gets shaded. So to do that, we want to graph the related equation, determine whether that boundary line is going to be solid for a less than or equal to or greater than or equal to, or dashed for a less than or a greater than. We want to test a point to determine which half plane should be shaded, and then shade the half plane that contains the solution. So if that point works on one side of the line, that's the side of the line that we want to shade. If it doesn't work on that side of the line, we shade the other side. So let's graph the inequality x minus y is less than 3. In order to do this, I'm going to make it look more like slope-intercept form. So I'm going to subtract x on each side. So that gives me negative y is less than negative x plus 3. And I'm going to multiply the whole thing by a negative 1, so I get a positive y here. And remember that when you multiply or divide an inequality by a negative number, you flip the sign. So that's going to give me y is greater than x minus 3. So let's go ahead and graph the line y is equal to x minus 3. So that's a y-intercept of negative 3 and a slope of positive 1, which is up 1 and right 1, or down 1 and left 1. And because this is a greater than sign, not a greater than or equal to, I'm going to go ahead and draw this line as a dashed line. Now I need to determine which side of this boundary line I shade. To do that, I'm going to test a point, and the most common point to test is the point 0, 0. You can do this as long as your boundary line doesn't go through the origin. So I'm going to plug in 0 for x and 0 for y and see if my inequality is true. So is 0 greater than 0 minus 3? So I plugged in 0 for x and 0 for y. So is 0 greater than negative 3? Indeed it is. So here's where the point 0, 0 is. So I want to shade the side of the boundary line that contains that point. If 0, 0 did not work in the inequality, then I would shade the other side of the line. So what does this mean? That means that every point in this region, in this shaded region, works in this inequality, whether it's written like this or as we rewrote it so it looks like slope-intercept form. Here's a practice problem I'd like you to try, so go ahead and stop the video and do this one in your math journal. Okay, let's take a look at how we would graph this. So we have 2x plus 3y is greater than 18. First thing I want to do is rewrite that so it looks more like slope-intercept form. So I'm going to subtract 2x on both sides, and I will divide everything by 3. And because I'm dividing by a positive number, I don't have to flip my inequality. So I have y is greater than or equal to negative 2/3 x plus 6. So I'm going to go ahead and graph the related equation. So just imagine that that's an equal sign. So I have a y-intercept of 6 and a slope of negative 2/3. So that's down 2 and right 3, or up 2 and left 3. And because my inequality is a greater than or equal to, this is going to be a solid line. So I'm going to go ahead and draw a solid line. And now I need to decide which side of the line I'm going to shade. So I'm going to test my point 0, 0. So when I plug in 0 for y and 0 for x, 0, is that true? So is 0 greater than or equal to 0 plus 6? Is 0 greater than or equal to 6? It is not. So my point 0, 0 is here, so I can't shade that side because that point does not work in this inequality. So I'm going to shade the other side of my boundary line. all of this here. And don't forget, what that means is that every point in this shaded region, so for example, point out here, point 10, 10, would work in that inequality. None of the points on this side of the line would work in that inequality. So in this video, we took a look at how to graph a linear inequality in two variables. We started by rewriting the line in slope-intercept form if necessary, graphing the related equation, determining whether the line was solid or dashed, and then testing a point to determine which side of the boundary line we need to shade.